We're given the equation for the decomposition reaction of hydrogen peroxide, and we're asked to calculate the average rate of production of oxygen over a period of time. We're given a data table here. I just moved that over so I don't have to keep scrolling up and down. All right, let's work on part A. Calculate the average rate of production. Now this data table has given us information in terms of the reactant. So let's use that, and then we can convert that over to the production of one of the products. We can express the rate of disappearance of this reactant as a negative change in the concentration of the reactant, H2O2, over the change in time. If you don't have this negative sign, that's fine, because you just need to turn your rates of reactions into positive values at the end. Because reactants are being used up, this term will be negative, so that's why we put a negative there, to make it convenient to express all rates as positive values. Anyway, let's plug in these numbers because we're asked to calculate it between the first increment of time, from 0 to 2.16 times 10 to the 4 seconds. The rate that hydrogen peroxide is being used is equal to the final concentration, right, where concentration is in the second column of our data table, minus the initial concentration. So I'm just going to use molar to save some space. And then the time increment, final minus initial. So let's plug these numbers in. The numerator is just going to be 0.5 divided by 2.16 times 10 to the 4. Our given measurements have 3 significant figures, so let's report our answer to 3 significant figures. 2.31, 10 to the 5. The rate is the change in concentration over time, so it's molarity per second. Now this is the rate of disappearance of the hydrogen peroxide. The question is asking us the rate of production of oxygen. So the stoichiometry says that we're only going to produce half as much oxygen. So we just take this number and cut it in half. So our answer to part A is going to be 1.16. And you should use your stored numbers to do calculations and round at the very end. If you want to use moles per liter as your units, that can be your answer as well. So I'll also show my work. So the change in the concentration of the production of oxygen over the change in time is equal to the negative 1 over the coefficient change in the concentration of the reactant is hydrogen peroxide over the change in time. And that's how you get the answer. All right, let's work on part B. Part B, asking the same question, except now we're given a different time increment. Let's get the rate of disappearance of hydrogen peroxide in this time increment. So here's our final, and here's our initial. So the rate that hydrogen peroxide is being decomposed is again going to be negative. The change in the concentration of hydrogen peroxide over the change in time. All right, the numerator is going to be 1/4 of a mole, and the denominator is going to be 2.16 times 10 to the 4. So our answer reported to 3 sig figs is 1.16 times 10 to the negative 5 molar per second, or like previously, you can do moles per liter second. They mean the same thing. Oh, that's not our answer. That's the rate of the hydrogen peroxide being used up. So remember, the oxygen is being produced at half the rate. The stoichiometry tells us that. So every 2 molecules that hydrogen peroxides decompose, we get 1 molecule of oxygen. So let's take this number in our calculator and cut it in half. So the rate that oxygen is being produced in the second time increment is 5.79 times 10 to the negative 6 moles per liter second.